tab, and then you want to specify, check column and row headers as well as grid.
Okay.
Then it will print out exactly the way it is appearing on the screen.
Okay. Will it print out, an infinite amount of rows or columns, or it just prints out to the last one that's used?
It will only print out the cells that have data.
No. Okay.
Yes.
Well, it'll fill in all the blanks, but
Yeah, you can use scaling to, to specify, how many. You can specify how many pages you want to use to print out the entire thing, so you can shrink and expand, as necessary.
Okay.
Yeah. And you can also control the scaling factor if you want to manually control that. Yep.
For row 14.
Hold on a sec. Let me get rid of this. Yeah, row 14.
I noticed on one of mine, I did it by accident. Is it going to be a big deal if I had to put return 2 instead of 1 plus 1? Or is that?
I wouldn't take too many points off, but it is still technically what.
Okay.
It's not what the return statement does.
Okay.
Yeah. But, I understand that it is resolving to a 1 because, if you know 1 plus 1 is 2, that means the question mark is a 1.
Okay.
Yep. Okay. Any other questions about this question? Any questions about this one? Okay. Let me close it. And this is also something that you should remember to do, is to close the document before you upload in the test. Okay? Because if you don't do that, it is possible that you have a document that you have finished on the screen, but it is not saved. So you're uploading a version that is not completed yet. Yep.
Are you going to upload that to Moodle?
Sorry?
Are you going to upload that to Moodle?
Yeah. Yeah, just like the one that I uploaded on Tuesday. Okay. Have we talked about question number 3? Was I done with question number 3 on Tuesday? Sort of?
Yeah,
No? Okay, let me see. I don't even have a text file saved on Tuesday, so that means, I probably have not fully tackled that question yet, so we'll do it today. Okay. So for question number 3, the key is to look at it from a pictorial perspective, okay? Because it is somewhat complicated if you try to do it, just by looking at the text. So the one thing you can do is to look at it, from a pictorial perspective. And unfortunately, if you're turning everything in by electronically, it's really hard to include a picture along with, the description. You can use Paint, to draw something, but it's going to be a pain in the butt to try to upload it and make sure it looks okay in the HTML document and stuff like that. It can be done. I'm not sure it's worth the trouble.
You can
Okay.
drop a picture back straight into Excel.
Yeah. Yeah, but this one has an HTML answer box. You can still upload something and make a link to it, but it's going to take a lot more time. But you can still do it, on a piece of paper, separate from that thing. So what I'm doing right now is I'm drawing a picture that represents the logic of the pseudocode. So let me just go scroll back to the pseudocode. And obviously this part cannot be captured onto the screen capture because I'm doing it on a regular whiteboard. Okay, this is the overall shape of this algorithm. We have 2 independent conditional statements, and each one only has a then portion but not an else portion. Okay? A conditional statement that does not have an else portion still have 2 options. Okay? It's just that one option does not have anything to do. Okay? The first one is if x is x, yeah, x mod 2 equals to 0. That's the question that we are asking. If it is true, we go this way. If it is false, we go the other way. In the second conditional statement, we are asking, is x greater than 30? If it is true, we go this way. If it is false, we go the other way. So this is the overall structure of the conditional statements. You have to remember that we do not, in this case, have a conditional statement inside another conditional statement. They are basically, one is following the other one. Okay? And the action we perform here is one is x gets x plus 1. The other one is x gets x minus 3. So this picture now completely represents, the code that we are seeing on the screen. What you are given is this condition. By the time we get here, which is post 37, at this point we know for sure x equals to 28. So you can just kind of imagine that your program crashed at this point, or you know the program is not right at this point, and x somehow has a value of 28. So you want to push the logic backwards and see, okay, if x is 28 at this point, can I say something about what is the value of x on line 32 without actually running the program again and put a breakpoint on line 32? Okay. Is that making any sense? Okay. Now, between this point here, which is post 37, and this point here, there's no code in between that can change the value of x, which means whatever the condition is of at post 32 still has to be true here. Excuse me, post 37. So that tells me that this at this point here, right after x gets x minus 3, I also know that at that point x equals to 28. Okay, if we chose to take that branch, okay, x would still be x would be 28 after we subtract 3 from x. Okay. Now, if you go backward even one more step, if I know after the subtraction x has a value of 28, what is the value of x before the subtraction?
31.
31. Now, remember, when you're walking backwards, you don't have to use substitution and inverse functions and stuff like that. You can just kind of vaguely explain your rationale. So we know that at this point, x will have a value of 31. Okay, is that working out so far? Okay. Well, but this is not the only way to get to post 37. There's the other way to get to post 37. So that means I also have to kind of think about when I am in this path here, what can I say? There are two things you can say, not just one. Because in this case, you know that x is 28 because nothing happened between this point and this point. And as a result, you know that if x ends up with a value of 28, x still have a value of 28 when we take the false branch. Is that okay? Mm-hmm. But since we are in the false branch, there's one more thing that we also know, because we also know that this condition has to be false. Right? So x has to be less than or equal to 30. And there's no conflict. Okay? There's no conflict. So this is okay. Okay? There's no problem at this point. Okay, so if you merge these two paths, okay, this one is saying x equals to 28 because this part is useless. And this path is saying that x equals to 31. So that means by the time these two paths merges when we go backwards, at this point, all we can say is x can be 31 or x can be 28. Are we doing okay so far? Because when you're moving backwards, you don't know which way you came from by the time you get to this point. As a result, you can only say that, well, at least one of these two conditions has to be right. Okay? And in this particular case, yes, you can say either or, but I would still just use a regular or. Any questions? Okay. If I know x equals 31 or x equals 28 at this point, well, I can use exactly the same logic and say, well, it will still apply to these two other points. However, there's one thing, well, we'll get to that point. If I know after the adding 1, x can be 31 or x can be 28, what can I say about x before adding 1 to it?
30.
Mm-hmm. So x equals 30 or x equals 27 at this point. But we're forgetting one thing. The conditional statement is putting an extra constraint on everything. So you have to say that, yes, we know this from pushing the condition backwards, but at the same time, because we are taking the true branch in this case, we also know that x mod 2 has to be 0.
Which means x came out to 27.
But we'll deal with that later. Okay, we'll say x mod 2 equals to 0 and that. Okay, the little wedge symbol is the and symbol in mathematics. Okay, well, that's kind of interesting. Okay, we'll talk about what that means later on. But at this point, does everybody agree that we have to place an extra constraint on the condition? Because otherwise, we would not have been going to the then branch. Yep.
What does that say? X mod 2 equals what?
x mod 2 equals 0.
Oh, okay.
Yeah, programmers write 0 with a slash
Oh, okay. Okay.
to differentiate 0 from O.
Gotcha.
Well, but that tells you something else too, because on the right-hand side, on the false branch, we also have an extra constraint, don't we? Because at this point here, knowing that I'm on the else branch, we also know that x mod 2 has to be different from 0, and x equals 31 or x equals 28. Because if x mod 2 is not different from 0, I would not have been taking this branch. Are we doing okay so far with the extra constraints? Okay, now we'll go ahead and see. This is awfully complicated, and this is awfully complicated too. Can we simplify? How can we simplify something that looks kind of nasty like that?
X equals 30 or 31.
But I want to explain how to do it, the rationale of doing it. So first of all, we'll take a look. I'm just copying the condition over here. X equals 28 or x equals 31. And then the whole thing ended with x mod 2 equals 0. See it? No, the other way. That's not equal to 0. Okay. So if we look at this expression here and say, can we simplify this? Okay, we know we can simplify that somehow, but the question is, how can we simplify? What is the rationale of doing that? Okay. You look at the left-hand side of the conjunction. How many points is it representing? It's representing exactly 2 points. Okay, x can be 28 exactly, or x can be 31 exactly. So when you look at the left-hand side, we have 2 points in some space, and then one is at 28, the other one is at 31. Yep.
Why is it at 28? Why isn't it at 27 on x equals 28? Why is it
Because on one side,
The false branch.
we have gone through the x gets x plus 1.
Okay.
Okay, and because we know that x equals 31 or 28 after adding 1 to it, so that means before we add 1, x can be 30 or x can be 27. So that's why they're asymmetric. Okay. What about the right-hand side? What kind of value are we talking about when x mod 2 does not equal to 0 and x is an integer?
Odd.
It is odd. Okay, it's an odd number. So that means on this side, x can be 29, x can be 1, x can be negative 13, x can be 201, and so on and so forth. Okay. When you perform a conjunction, you're looking at the intersection between those 2 sets. Okay. One set only has 2 items. The other set has basically an infinite amount of items. But is there an item that is shared between these 2?
Yes.
31 is shared, right? So if you look at one side like this bubble here, and the other side like this bubble here, they intersect at exactly 1 point, which is 31. So that tells you can simplify this entire thing and just say, oh, so all it's saying is x equals to 31. So that's one way to look at this simplification. There are other ways too, using Boolean algebra. Yep.
Now, are you saying that because 31 is an odd number?
Yes.
Okay.
Well, it is both an odd number and also the other side lists, x equals 31 is a possibility.
Okay.
And the computer has gone to sleep.
Okay, I see what you're saying. Okay.
Yep. The other way to simplify that is to use the distributive law of Boolean algebra, which we haven't talked about in the class, so I can't really use that as a rationale. Okay? So using the same rationale, we can basically just say that, at this point here, if we simplify this whole thing, it simply means that x equals to 31 on one side, and on the other side, if we simplify this whole thing, what can we say? Well, x mod 2 equals to 0 means that x has to be even, and you look at the other side, only one choice is even. So that means you can